Now, Schrödinger was interested in a different aspect of things than Heisenberg. Schrödinger was fascinated by waves, by pictorial representation, by intuitions, by trying to make these things as clear as possible to our grasp. He wanted to use constructive and destructive interference of waves to explain everything. In this, he was much closer to Einstein. Schrödinger came of age in Vienna at a time when there was a kind of advanced culture, the secessionist artists, for example, Gustav Klimt, the new kind of Art Nouveau that was developing at the time. Schrödinger carried around an image from a science club that had been redone from one of Klimt's erotic paintings called Blood of Fish, and he kept that his whole life. Schrödinger was as sort of interested in sensuality and Eastern religion as Heisenberg was interested in the kind of strict asceticism of his scouting world. Heisenberg wanted a minimal depiction of the world through these arrays of numbers. Schrödinger wanted a pictorial understanding of what was going on. Schrödinger derived many of his views from Arthur Schopenhauer, the early 19th century philosopher, who wrote The World as Will and Representation. It was work that was taken up by Freud, by Einstein, by Wittgenstein, by Wagner, by Jung, by Tolstoy, by many people. And Schrödinger was fascinated by this idea of our representations being partly constitutive of the world. In this, he was more a follower of Kant by far than Heisenberg. So Schrödinger would ask himself these questions, even in 1925, at the time he was height of working at these questions of quantum mechanics, asking, does an I, like, do I exist? Does a world exist besides me? Do I cease to exist on bodily death? Does the world cease to exist on my bodily death? And then he categorized the different responses to these four questions as to what was coherent and what was not. Schrödinger, like Heisenberg, was interested in philosophy, but the philosophy of Schrödinger was much more based on Eastern religion, on Schopenhauerian, neo-Kantian philosophy, than the kind of reach to the classical and the ancient Lucretian and other atomistic philosophies that Heisenberg was riveted by. Schrödinger lived a much more erotic and, some would say, dissolute life than Heisenberg. For example, he was married to one woman who was involved with Hermann Weyl. He had a child with a woman named Hildegrunde March, and Hildegrunde was married to Arthur March, who was Schrödinger's assistant. Schrödinger was constantly getting involved with different women. He was constantly moving around in his philosophical and speculative aesthetic commitments. He was committed to this idea of finding an intuitive, graspable way of understanding the world, much closer to Albert Einstein than to Heisenberg. Schrödinger found Heisenberg completely repellent. As he put it, my theory was inspired by Louis de Broglie and by short but incomplete remarks by Albert Einstein. No genetic relation whatever with Heisenberg is known to me. I knew of this theory, of course, but felt discouraged, not to say repelled, by the methods of transcendental algebra, matrices, which appeared very difficult to me, and by the lack of visualizability. Heisenberg returned the favor in saying, the more I reflect on the physical portion of Schrödinger's theory, the more disgusting I find it. What Schrödinger writes on the visualizability of his theory, I consider trash. These debates over what was wanted from a theory were fundamental. There was no physics outside of epistemology and philosophy. This was trying to grasp what concepts were, what the basic notions of physics should be. In this, they, no doubt, were thinking of Einstein, whose criticism of simultaneity, of time and space, was so fundamental to the onset of this new kind of physics. Heisenberg, in 1926, had exchanges with Schrödinger and Bohr. And he later tried to reconstruct what those exchanges were like, recalling the battle back and forth that went on at a railway station in Copenhagen. Schrödinger. Bohr. The whole idea of quantum jumps necessarily leads to nonsense. It is claimed that the electron in a stationary state of an atom revolves without radiating. There's no explanation. Bohr. Yes, you're completely right, Schrödinger. But that doesn't prove that there are no quantum jumps. It only proves that we can't visualize them. That means that the pictorial concepts we use to describe the events of everyday life and the experiments of the old physics do not suffice. Schrödinger. As soon as we are ready to change the picture so as to say that there are no electrons as particles, but rather electron waves or matter waves, everything looks different. We no longer wonder about the sharp frequencies. The radiation of light becomes as easy to understand as the emission of radio waves by an antenna. Bohr. No. Unfortunately, that is not true. The contradictions do not disappear, they are simply shifted. Think of the Planck radiation law that was based on the idea that things could radiate and absorb only in fixed states, not continuously. It is essential that the energy of the atom have discrete values. Bohr continues. We see the discontinuities, the jumps, quite directly in atomic phenomena, perhaps on a scintillation screen or in a cloud chamber. You can't simply wave away these discontinuous phenomena as though they didn't exist. Schrödinger. If we are still going to put up with these damn quantum jumps, I am sorry that I ever had anything to do with the quantum theory. Bohr. But the rest of us are very thankful. Your wave mechanics in the mathematical clarity and simplicity is a gigantic progress. What Bohr and Heisenberg and Schrödinger put together in this period, and as it was adumbrated by Max Born, who gave it a probabilistic interpretation, was what came to be known as the Copenhagen interpretation. It had a few simple rules that could become quite complicated in their application. But it said, first, a quantum state is defined by some quantity we'll call psi. The probability of being in that state is the square of psi. The state of a physical system is the sum of all the physical possibilities of how that could be configured. For instance, an electron going through one hole in a two-slit experiment would be psi1, and going through the other hole would be psi2. So the state of the physical system would be psi1 plus psi2. Measurement, the fourth aspect of this, the part that has created such conceptual problems and worried people so much over the years, measurement fixes psi. That is to say, we never see superposition. We never see a particle going through both holes at the same time. Schrödinger and Heisenberg's battle could be thought of in this table form. Schrödinger wanted a visualizable physics. Heisenberg wanted to instantiate Bohr's idea that you shouldn't try to visualize things that weren't visualizable, like what happened as an electron went from one orbit to another. Schrödinger wanted a continuous description of the world. Heisenberg wanted a discontinuous description of the world. Schrödinger wanted causality to be preserved, as Einstein did. Heisenberg was not at all interested in preserving classical causality. Schrödinger wanted a wave mechanics. Heisenberg wanted a matrix mechanics, a simple ascetic array of numbers.